Welcome to another math video. In this one, we're going to look at section 4.7 in the pre-calc book, our continued journey into inverse trigonometric functions. In the day 1 video, we saw how it worked with arcsine or sine inverse. Now we'll talk about some of the others. So the cosine function is decreasing and one-to-one over a different interval than sine, as shown in the figure. So the light gray graph is cos, and notice we're going here from our first peak right on the y-axis until we hit our first valley at pi. So that means we have accounted for every number on the y-axis from positive 1 to negative 1. Consequently, on this interval, cos function has an inverse. Remember, to be an inverse, we need to pass the horizontal line test, and if we do not restrict the domain, we would fail that horizontal line test. So this is denoted by y equals the arc cos of x, or cos inverse. Cos with that negative 1 exponent, just like with sine, arc sine, and sine inverse, these are interchangeable. Similarly, you can define the inverse tan function by restricting the domain to positive negative half pi, just like with sine. The following list summarizes the definitions of the three most common inverse functions. So let's check this out. Here we go. We got a table up top and we got some graphs below. So arcsine, the domain, you're only allowed to put in numbers between 1 and negative 1. Outcome angles in the first and fourth quadrant from positive to negative half pi. Arc cos has a same domain, negative 1 to 1, but now the range, the outputs are a little different, only angles from 0 to pi. Arctan, the domain is very different. We can put any number into arctan, and the numbers that are going to come out, the angles that come out are the same as arcsine, positive to negative half pi. The graphs are shown down here below. The graphs, I will not test on those, anything like that. I want to show you this, I think, is a little more important. I'm going to draw the quadrants, x and y axes. Remember, it's all about the neighborhood. You want to stay in the neighborhood for the inverse trig function that you're dealing with. So I'm going to use color-coded here. Arc sine, I'm going to use red, and that's positive to negative a half pi. So that's these two quadrants. We could open up this way to positive a half pi or this way to negative a half pi. So this red rectangle, that is the neighborhood for sine inverse or arc sine. I'm going to switch to blue ink. Arc cos has the same domain, but the range is 0 to pi. So if we start at 0 and open up an angle to pi radians, that's going to be the blue rectangle. That is going to be arc cos or cos inverse. Tan, let me switch to, I guess, green ink. Arctan has the same range as sine inverse. So let me just put a green rectangle kind of around this red one. So arctan, or tan inverse, lives in the green rectangle. When you're looking for an answer to these inverse functions, you've got to stay in the neighborhood where it is defined. Sine and tan in quadrants 1 and 4. Cos in quadrants 1 and 2. You got to stay in the neighborhood. Notice you never go through the third quadrant, because remember, if we're doing arcsine or arctan and we want to go into quadrant 4, you're not going to go all the way around to get there. That's the long way to get there. You've gone through cos inverse's neighborhood, you've gone through quadrant 3. You don't want to do that. Just do a negative angle to get you there quicker, because you don't want to ever go through the third quadrant. Why not? Because my house is right down here and the third quadrant is my lawn, and I hate it when teenagers go goofing off on my lawn. Stay off my lawn! Exclamation point. Don't go crossing my lawn to get down here to the fourth quadrant because you want to find a sine or tan inverse. Just do a negative angle. Stay off my lawn. And here we go. Ooh, I think, let me pause the video here and acquire a unit circle. Abracadabra, there's our unit circle. And again, just since we have this here, remember arc sine is here. Arc cos is up here. Arc tan is down here, same as arc sine. Quadrant 3 is my lawn. And here we go. Oops, I guess these are all individuals. So, arc cos, root 2 over 2 positive. Remember, arc cos, we're staying in the top half, quadrants 1 and 2. So cos is our x values. We want an x value of root 2 over 2. Here it is, but it's negative. So here is x value root 2 over 2, and it's positive. What angle made it happen? Pi over 4. So this is equal to pi over 4. Up next, the cos inverse. Notice they changed the notation a little bit. Same thing. Cos inverse, -1. So again, staying in the good neighborhood, we want to find an x value of -1, and there it is. What angle made that happen? Well, that would be the pi radians equals pi. All right, up next, arc tan. Remember on the unit circles I gave you to take home, I did put the tangent values outside here in a circle. I wrote it and circled it. So if you want to find a tan value of 0, that would be right over here. So the arc tan of 0 is just 0 radians, or 0 degrees, whichever. All right, next up, tan inverse of -1. Remember, everything's positive in the first quadrant, so this has to be in quadrant 4. And our tangent value, you'd see a -1 right here. So what angle made it happen? Oh, that answer is 7 pi over 4, right? No. If you write 7 pi over 4, that means you went through the first quadrant, you cut through cos inverse, and then you stomped all over my lawn to get there. So 7 pi over 4, I'm going to mark that wrong. We need the quicker way to get there, negative angle direction, negative pi over 4. Stay off my lawn. Just another unit circle. Example 4. We got some of these we're going to do on a calculator. So use a calculator to approximate the value if possible. And let's make sure our calculator is in rad mode. And let's see here. It says warning. Remember the domain of the inverse sine. Cos is -1 to 1. Okay. So arctan of -8.45. Arctan you can put anything into from -1 to 1. So again, I'd make sure my calculator is in rad mode. And let's round these to 4 decimal places. Arctan of that is going to be a -1.453, and if we kept going, it'd be 0.001. So if we usually round to 4 spots, we would just round that to 0.453. All right, up next they changed from arc to inverse notation, but that's fine. Punch in 0.2447, second function, hit the sine key. Let's round this off, approximately 0.2472. Now, if we type this next one in on the calculator, type in the 2 and hit second function cos, your calculator is going to say error. E-R-R-O-R, there we go, error. Because remember, if we were doing the cos, we put angles in here. Angles go in, and out comes a number between -1 and 1. So when we invert, when we're doing the cos inverse, the only thing we're allowed to put in there are numbers between -1 and 1. If we try to put a 2 in there, it's outside the domain. So we are going to get an error that is not defined. And time for a little practice. So pause the video and try these out. Start the video back up and see if you got them right. The first 2 you should get without a calculator. Next 2, calculator is preferred. Okay, So let me acquire a unit circle. Abracadabra. There it is. And let me move these over here. I guess I'll move this down here because remember arc cos. The neighborhood is top two quadrants, quadrants 1 and 2. So arc cos of a half, where is our x value positive a half? Ooh, there it is. What angle made it happen? Pi over 3. Pi over 3. Up next, arc tan of root 3. Remember now, arc tan is only over in the first and fourth quadrants. And because it's positive, we know we're going to be in quadrant 1. And that square root of 3 happens right up here. Square root 3 for tan. What angle made it happen? It's the same angle. Pi over 3. Same answer for both of those. Now, what do we got down here? Get out of the way, unit circle. Ooh, now I'm looking, I got an old set of notes here. And these are a little off, so I got my calculator right here. And I'm in rad mode. I'm going to type in 0.41 and make it negative. Second function cos. I've got approximately 1.99325, so that'll round up to a 33. 1.9933. Oh, no, whoa, back up. Round your answer to 2 decimal places. That's interesting. They only rounded to 2, so that would be 1.99. Up next, arc sine of that. 0.125, I make it negative. Second function sine, I get approximately negative point. Well, again, to 2 places, this is 1.25, so that would be 1.3. Or excuse me, 0.13 as the arc sine of that. Is that it? Unit circle. Yeah. Now this assignment, I might find some of this on WebAssign, so that might not be the assignment. We'll talk about that in class or look for it on Microsoft Teams. I hope this video helped.